Okay, so this will be the second drive axle and carrier fundamental video. This is, again, some of these PowerPoint pictures will be the same as the on-road stuff. So let's take a look at some of the things we should be looking at. So number one is, how is it lubricated? Well, depending on the application again, some of it is splash lubricated. So as the pinion turns, it picks up the oil and it feeds that oil up into the pinion bearings. There are some systems that are pressure lubricated, and we'll take a look at those later. So one of the big things that we should be looking at is the level of lubrication and the type of lubrication that is required. So having the wrong lubrication or lubricant in the differential could be harmful to it. Now, like I said earlier, one of the big things that we'll notice if we start to have a failure is the temperature will start to rise. Now, there's a couple things that we can be doing to take a look at what's going on. Is the level too high? Is the level too low? Do we have a problem going on with the diff? So again, one of the big things we can do is what's called a plug swap. So on the bottom of the differential, there is a magnetic plug. So what we can do is we can pull that plug out and quickly replace it with another plug and see what type of material we're getting on that plug. And that will give us an indication if we're having a failure. I was doing a plug swap one day and no oil came out, which was odd because there was oil in the diff. And what it was, there was so many pieces of metal around the base that it plugged off the oil. Once I took a screwdriver and poked it up in there to break the pieces away, oil started to flow. So diff has to come out. So again, always look at the oil to see, do we have any silver in the oil? So don't just go, yeah, there's oil in there and forget about it. Take a look at it. If there's silver in there, we're picking up the silver from somewhere. So we want to know where. Again, some of the systems are pressure lubricated. So again, we need to be aware and make sure that the level's good and also that the pump's working. The other thing that we should be taking a look at is breathers. Now, in a lot of cases, the breathers are attached right to the housing and they get plugged up with dirt, snow or something, and the breathers stop working. Well, what happens as the oil starts to heat up, the pressure inside that differential is going to increase, and path of least resistance, it will blow out a seal, whether it's a wheel seal or a pinion seal, it will blow out a seal. So anytime that you have to replace a seal, just check the breathers to ensure that they're free and not plugged up, because you don't want to be replacing that seal again on your own dime. Another thing that we should be looking for is anytime we're going to be doing a service, before we wash it, just take a quick check to see if we can see any cracks anywhere. And a good indication that there's a crack is if there's oil around somewhere, especially if it collects dirt. Before disassembling, we should be checking to see what our specifications are. For instance, if we put a dial indicator on the front of the pinion shaft and move it back and forth, does it move? Does it move up and down? You know, what are our end plate and do they fall within the specifications of the differential? Now, again, some of the things that we should be taking a look at for probable causes. So, noise on drive. So, excessive pinion to ring gear backlash. Okay, so that's in one of our settings, which we're going to go into later on in this PowerPoint. Worn pinion and ring gear. Now, in some of these cases, there's just an adjustment, and some of it we have to replace. Worn pinion bearings. So if we have a loose pinion bearing, okay, so what happens there is the pinion nuts come loose. So it could be just a matter of replacing the pinion nut and retorquing it up properly. Excessive pinion end play, again, it's just an adjustment. Worn carry bearings. Now again, if we've got it apart and they're worn, it's probably best to replace them. If they still look good, yeah, then we can just do an adjustment. Excessive ring gear run out, and this is where when we put a dial indicator, and you'll see later on we take a look, On the back side of where the thrust screw goes, we're going to put a dial indicator on there, and we're going to do run out. And if it's excessive, that means that it's wobbling in back and forth, and it means it's going to change what our contact areas are. Low lubricant level, again, we can replenish those. Warren grade of lubricant, and that's from not doing services on a regular basis. You know, let's just say every 2,000 hours that oil has to be changed. If it isn't, the additives are going to wear out, and with that, we're going to lose our extreme pressure lubricant. Because you think about a crown and pinion as they're rubbing together, and our pinion gear is pushing against our crown gear. As it makes contact, that oil that's in there is going to be squeezed out. Now, if the EP additive is worn out, the extreme pressure additive's gone, where that makes contact could weld together. And as it welds together, it'll break apart. And that's where crown and pinions start to fail, is now we start to get some metal floating around. So it's only going to get worse. And that's why anytime we take crown and pinions or carriers out, we should always take a good look at the contact areas and see if they are starting to wear. Now, a bent housing is another thing. And how do we tell if we have a bent housing? Well, the easiest way is to pull both axles. Now, anytime we remove a diff, we're going to have to pull both axles in order to get the differential out. And before we pull the differential out, if we go back on one side and look through the center of the axle, you'll see the hole on your side where the axle goes. Then you're going to see where the cross is, and then you're going to see the far end of the axle. And if you look and line up your side with the center, the hole on the far side should be centered. If it's not, you probably have a bent axle. To fix that, you're going to have to put it onto a press, and it's got to be pressed. Now, these presses are fairly big, like as a frame machine. A normal just press isn't going to do it. Noise on coast, and we talked about this in an earlier video. Axle noise heard on a drive will usually be heard on coast. Okay, and what's caused that? Pinion nut. Okay. Intermittent noise, warped ring gear, loose carrier case bolts. A constant noise, flat spots on a pinion or ring gear teeth, flat spots on bearings, worn splines, worn axle shaft dowel holes. So there's a lot of them, but again, taking a sample of the oil, taking a look, again, you may have to pull it apart to find out what's causing it. Noise on turns, okay? The side gear pinions are starting to wear, so we're going to get noise on that. Warren carrier spider, and that's the cross is worn itself where the pinion gears run. And worn axle shaft splines. Now, worn axle shaft splines could be caused from a couple of things, and we got to take a look at how they're set up. So our axle slides into our side gear. Now, if our axle housing's bent, it's going to bend and it's going to force those gears not to run true, and it's going to wear out. Again, path of least resistance, what's the easiest thing to wear out? And it's usually the splines that are on the axle or in the side, inside the case, half the side gears that will wear out first. So that's why it's always a good idea to pull it apart and check it. Now, the other thing is components left out in the snow without being properly protected. Water gets inside of it, and we don't notice. Now, I had one truck at one of the shops where middle of winter they couldn't move. So first thing you think of as well, the brakes have frozen. So you take a torch, you heat those up. Those were free. What had happened, so much water had got into the differential because they were hauling in the bush, and they brought the truck in, parked it outside our shop. Overnight it froze, and the water in the oil froze. So once we warmed up the diff, brought it in the shop, we could drain all the water out. So always, check those. So Some vehicles require considerable disassembly before removing the differential, so you may have to remove half the vehicle depending on how the differential's set up. Now, another thing is before we remove a differential, the axle shafts have to be removed. First thing you have to do is block the wheels, because as soon as we remove that, depending if we have an internal brake, as soon as we remove that, there's no brake anymore and the vehicle can roll away. So always block the wheel before you're doing anything with the planetaries. Once everything's disconnected and our axle shafts are out, we can pull our differential out. And again, it's not something that you should be trying to lift by hand. I worked with a guy that tried to pull one of these out of a highway truck, and he had to have 4 vertebrae fused in his back. So always make sure that you use proper lifting equipment. Next thing we want to do is have a proper stand for it so that we can inspect it. So again, once we get it on the stand, we should be taking a look at it, and we want to record what the backlash is. So the backlash is you got to hold the pinion nice and tight, and you're going to move the crown gear back and forth and see what we get on the dial indicator for backlash. Now the backlash, if you remember, is the clearance that's between the crown gear tooth and the pinion tooth. And we need that clearance for expansion. So if it has a locker on it, again, the axle shaft slides into this locker and then into the side gear. So depending on the application, you may have to put a lock bolt in there or remove everything to get this apart. Then, if this has never been apart before, we want to mark our bearing caps. We got to be really careful when we're taking these apart and putting them together, because inside this adjustment ring is some threads, and if we accidentally torque this down and with this nut in here and it cross threads, this whole case is garbage. We can't reuse it because we can't adjust it properly. So this is an adjustment tool, and this is for adjusting our bearing preload on our crown gear. So we're going to use this. We're going to back this bearing off on both sides, and then we're going to take and pull the caps off. Once we get it all apart, this is our case half. This is our crown gear, our case half, and this is our spider that runs inside. So we'll have our pinion gears in there and our side gears. Once we take our pinion out, this is where we're going to check our bearings and our pinions. So we have 2 cone bearings in here with a spacer. And this has to be set up so we get a certain amount of rolling torque. So once we get it out, we're going to put it on a press, and we're going to support our case, and we're going to press our pinion out. And this is the spacer that's in between the 2 bearings. Now, if we're replacing the bearings, we have to, well, whether we replace them or not, we still have to make sure our rolling torque is set properly. Now, we all know how to inspect bearings, so I don't need to go over that. So some of the other things, again, we want to inspect. We want to inspect our gears, our crown gear, our pinion gear, our pinion carrier gears, our axle shafts, our cross. We want to inspect all of these. The one that doesn't show is our side gears. And don't forget to inspect the case halves, because on the back of this pinion gear there is a thrust bearing or a thrust washer. And that thrust washer, if it gets loaded up, can spin in the case half and take the case half out. So because the crown and pinion come as a match set, they have to be changed as a set. Otherwise, they're just going to run really noisy together. So again, we want to know what's caused it. So if you remember back from first year, we talked about beach marks or benchmarks. And those are marks that are left on a gear that shows a progressive failure. Now, it usually is a smooth smoother finish, but you can actually see these marks that are left on the gear itself. Anytime that we have a failure, we want to know what caused it. So it's not something that you want to memorize. You're going to look it up in a book to find out what the failure was. So again, it might be a warranty item, it might not be. Now, one of the things we talked about is when we go set everything back up on our pinion is rolling torque. So what we're going to do is we're going to push down on our cover. And what we're checking is what is our rolling torque of this front cover. And what happens when we push down on this part here is it pushes the two bearings with the spacer together, and that spacer gives us our clearance or our preload. So what we want to have is X amount of rolling torque, and we use a fish scale for that. The other thing is what's called a nominal dimension. In the first video, we looked at the bottom of the pinion, and it gave us a dimension. It said +2. Well, so the nominal dimension is what the manufacturer says is 0. So a +2 on the pinion would mean that the pinion is 2 thou further away from the center line. So let's take a look at a pinion. So this pinion has a +3. So it means that it is 3 thou away from the nominal dimension. So it's further away. If it had a -3, it would be 3 thou closer. And what they do is they run these and they move the pinion in and out till it gets the quietest and it gets the right contact. And then they'll mark it on the bottom. You may not see that anymore, but on some of the older ones, it's still there. So again, a positive number moves it further from the center line, and a negative number moves it closer to the center line. Now, how do we shim for getting our contact? Well, there's two different ways. In most highway trucks, we shim it with shims underneath, and this will move the pinion further away. But there is some where we shim it underneath here. When we add shims, it moves it closer. So be aware of how you have to shim it. Now, for instance, on yours, if we have a +2 on our old pinion and we have a -2 on our new pinion, we're going to have to subtract 4 thou of shims to get it to work. So this is a chart that you use. Now this is the other style of pinion where again we're putting spacers at the bottom end instead of the top end. So this would be the opposite. So this is a chart for this one. Okay, checking our differential gears for rotating torque internally. So this would be an axle shaft that we have cut and welded a nut on and putting in, and what this is going to do is going to rotate our side gears to see what our rotating torque is internally. Because if it's too little, it means we have too much clearance internally. If it's too tight, that means we don't have enough clearance. Now, once we get this all ready to reassemble, we're going to put our pinion in. We're going to take our case and we're going to tighten these side retainers up, and that's going to give our preload on our crown gear. And there's a certain amount of rolling torque you want on that. So one of the things that we want to look at is what type of they call it a profile or a pattern. So now again, if we have to adjust for backlash, we have to move our crown gear. If we have too much, we got to move it closer. If we don't have enough, we got to move it further away. So one of the things, let's just say I'm rebuilding the differential and I'm resetting it. One of the things you'll notice is where the original wear areas are, and we're resetting it. So it's going to sit on that little that little section that hasn't worn. So what's that going to do once that section's worn off is it's going to, we're going to check our backlash and we're going to have very little, but all of a sudden after a couple months we have lots, and that's only because that little worn area is worn off. Now earlier on we talked about radial runout. So this is where we put the dial indicator on the face here and we rotate the crown gear and see what our runout is and see if it falls within the spec. We also want to check it here for the lateral or axial runout. Now we talked about profile or tooth contact. So what we want to know is, where is our tooth contact? We want it down, we want it in the middle of the tooth, not too close to the toe, not too close to the heel. And we don't want it on the face or on the flank. So we want it in this area here because we're only putting a small amount of load on. As soon as we load this down under load, this contact area is going to move up, and where we want it to run is always in the center. So too much face. So this is our face. Down inside is our flank. So again, face and flank move the crank, and our crank is our pinion. So when we move our pinion in and out, we're also going to have to reset it for backlash. So face and flank move the crank. Okay. Toe and heel move the wheel. So if we have too much heel or too much toe, we're going to move our crown gear in and out. Okay. So toe out, heel in. Face in, flank out. Okay, those are the two to remember. So toe and heel move the wheel, face and flank move the crank. Okay, face in, we're moving the pinion in. Flank, we're moving the pinion out. Toe out, heel in. And the reason I want you to remember this is because you're going to probably be asked for this on your SLE. Okay, that's the end of video number 2.